With chemistry. This is Russ Dollinger here. I wanted to go over something that I've created here. Many of you have trouble probably with ions and how ions are made and how they're connecting together and so forth. So let's go over a few of the flashcards in here. I cover 81 of the most common flashcards. They're available on Amazon, got 4.9 stars and 31 reviews. It's doing really well. All right? To struggle with chemistry. If you're having trouble with it, I'm willing to bet that a lot of it has to do with not understanding basic concepts, names, charges, symbols, or some of the other things. So I want to just go over it very briefly. So an ion is an atom that has gained or lost an electron. That's all there is to it. Gained or lost an electron. If it loses an electron, it has more protons that are positive charged than it has electrons, so it has a positive charge. Like sodium loses an electron, becomes Na+. If, on the other hand, it picks up an electron to be more like a noble gas, like chloride picks up an electron to be like argon, then it has a negative charge. Now, positive and positive push away from each other. Away, 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 away. And negative push away from each other. But positive and negative attract. Okay? They say likes repel, opposites attract. That's all there is to it. Now let's go over just a few of these so you can see how this all fits together. Chemistry doesn't have to be hard with the right tools. And a little bit of work, you guys can ace chemistry without any problem. We're going to start with potassium. That's an alkali metal in the alkali metal group in column 1. If we turn that around, you can see that it's got a potassium. It loses one electron to become a K+. K+. It loses one electron. It happens to lose a 4s electron to be like argon. That's an alkali metal. If we look at an alkaline earth metal like magnesium, where'd my magnesium go? Oh, there it is. Here's my magnesium, okay? And magnesium loses 2 electrons. So it gets to be charged of 2+. It's in column 2. Everything in column 2 loses 2 electrons. And it's losing the 3s2 electrons. Let me get that a little closer. You can see it loses the 3s2 electron to be like neon. They're always going to try to be like a noble gas in the case of these basic ions. So if we look at aluminum, aluminum loses 3 electrons. So it gets a charge of 3+. And it ends up looking like neon again. They get to look like a noble gas in column 18. Now, if we look at an anion like chloride ion, here, let's turn that around. Chloride ion picks up an electron, it gets to be Cl-, and it picks up an electron to fill out the p orbitals, so it gets to be like a noble gas, argon in this case. And if we look at oxygen, oxygen changes its name a little bit and becomes oxide. Where'd my oxide go? There it is. So here's my oxide ion, and it picks up 2 electrons to be 2- to be like the noble gas neon. Guess what? They're all going to be like one of the noble gases. Any of these basic ions. Now, if we look at, let's say another one, let's take phosphorus. Phosphorus, you notice it changes its name. It adds "ide." Instead of phosphorus, it's phosphide. Okay, and it picks up 3 electrons to be 3-, to be like a noble gas, argon. Look at that. It's the same pattern. Now, the ones that do break the pattern a little bit are things that are like transitional metals. The transitional metals, for example, copper 1 is called copper 1 because it has a charge of +1. It loses 1 electron, but it loses it in one of these d orbitals, or the 4s orbital in this case. It loses it, and it makes it more stable. It doesn't get to be like a noble gas, but it makes it more stable. Now, there's a copper 1, it's a +1, but there's also a copper 2 that's +2. It loses 2 electrons to be +2. This one loses 1 electron to be +1. Okay? Now, when you put these things together, you always want to get to a charge of 0. So if you think about table salt, that's sodium chloride. Sodium loses 1 electron to be +1. Chloride picks up 1 electron to be -1. +1 is attracted to -1. 1 minus 1 equals 0. You always want to get to 0. Magnesium chloride is 2+. If you have a chloride that you're attaching to it, you need to have 2 of those -1 chlorides to balance the +2 on the magnesium. So I usually show that with the ionic bond disk model, but I think you guys get that. You always want to get to zero. Flashcards are going to help you a lot. There's a 20% discount on them right now, either from the Science Glen website or from Amazon. Go for it. It's going to really help you a lot. Why suffer? Make your life easy. All right? Thanks. Bye-bye.